air conditioning systems. To classify air conditioning systems based on the fluid media used. To discuss characteristics of all air systems, all water systems, air water systems and unitary refrigerant based systems. At the end of the lecture you should be able to list the factors to be considered while selecting air conditioning systems, describe major components of an air conditioning system, classify air conditioning systems and discuss advantages, disadvantages and applications of different types of air conditioning systems. Let me give a brief introduction to an air conditioning system. An air conditioning system consists of an air conditioning plant and a thermal distribution system. Air, water or refrigerants are used as fluid media for transferring energy from the plant to the conditioned space or from the conditioned space to the plant. A thermal distribution system is required to circulate the media between the conditioned space and the plant. Another important function of the thermal distribution system is to introduce the required amount of fresh air for ventilation. Let me show a schematic of a typical air conditioning system. What we have here is a schematic of a summer air conditioning system. So, you have the conditioned space here and the air conditioning plant, and there is a thermal distribution system, this blue pipeline with a pump or a fan. And in summer, as we know, the conditioned space is maintained at low temperature and humidity compared to the surroundings. So, there is a continuous transfer of sensible and latent heat loads to the building which need to be extracted by the air conditioning system. Okay. So, the fluid flowing through the thermal distribution system extract this sensible and latent heat loads from the building, okay, and it transmits this heat load to the air conditioning plant. In the air conditioning plant, the system consumes some amount of work input and ultimately rejects the heat to the surroundings. Okay. So, this is the typical air conditioning system with the basic components. And as I said, in a thermal distribution system, if you are using air as a fluid media, it is possible to introduce outdoor air for ventilation. For example, you can introduce outdoor air, okay, here itself, and you can treat the outdoor air and you can supply the outdoor air along with the recirculated air to the conditioned space, so that the ventilation requirements of the conditioned space are taken care of. Selection of air conditioning systems is based on the following criteria. First one is capacity, performance and spatial requirements. Second is initial and running costs. Next, required system reliability and flexibility. Then maintainability of the system. Then architectural constraints, etc. Normally, the relative importance of the above factors varies from building owner to owner and may vary from project to project. For example, some building owners may give more importance to initial cost and some building owners may give more importance to the running cost. Okay, so it varies from building owner to owner, and it also varies from project to project. Okay. Now, let us look at classification of air conditioning systems. Based on the fluid media used in the thermal distribution system, air conditioning systems can be classified as all air systems, all water systems, air water systems and unitary refrigerant based systems. So, let us look at these systems one by one. First, let us look at all air systems. As the name implies, in all air systems, processed air is the medium used in the thermal distribution system. Okay. So, the air is processed in the air conditioning plant and it is used as the fluid which flows through the thermal distribution system. And a blower or fan transports the air through the thermal distribution system. The processed air, when supplied to the conditioned space, takes care of the sensible and latent cooling loads and provides the required amount of fresh air for ventilation. And no additional processing of air is required in the conditioned space. So, these are typical characteristics of all air systems. All air systems can be further divided into single duct systems and dual duct systems, and single duct systems can be again classified into constant volume single zone systems, constant volume multiple zone systems, variable air volume systems, and the dual duct systems are classified as constant volume systems and variable air volume systems. So first let us look at single duct, constant volume, single zone systems. As the name implies, here we have a single duct. So through the duct either cold or hot air flows through the supply duct, but both do not flow at the same time. That means you do not have simultaneous flow of cold or hot air, either cold air flows or hot air flows at a given time. And the volumetric flow rate of supply air is always maintained constant. That is why you call this as constant volume systems. Okay, the volumetric flow rate is kept constant. And the single zone may consist of a single room or one floor of a building consisting of several rooms. Here the term zone refers to the space which is controlled by a single thermostat. Okay, and this could be a single room or it could be a large floor of a building consisting of several rooms. And cooling and heating capacity in these systems is varied by varying the temperature and humidity ratio of the supply air, by coil control or by phase and bypass control. So let me explain this system briefly. So this picture here shows a typical constant volume single zone system. So here we have a conditioned space, or we call this as your zone. Okay, let us say zone 1, and we have the supply duct and the return duct. So at this point some amount of recirculated air and some amount of outdoor air for ventilation purposes are mixed, and that mixed air flows through a cooling coil, a heating coil, and the supply air fan and a humidifier. Then this processed air finally is supplied to the conditioned space. And since it is a constant volume system, the volumetric flow rate of supply air to the conditioned space is kept constant. Okay, so since the load on the building may vary with time, we have to vary the cooling capacity. Okay, so this cooling capacity is varied by varying the temperature and humidity ratio of the supply air. Okay, volume is kept constant, so either temperature or humidity ratio or both are varied. How these are varied? The conditioned space conditions are sensed by a thermostat T and a humidistat H. The thermostat T is connected to a heating coil and or a cooling coil. Okay, for example, if the temperature inside the conditioned space is less than required, then the amount of cooling has to be reduced. So what is done is the signal is sent to the cooling coil. Okay, since the volumetric flow rate is kept constant, the capacity of the cooling coil is reduced to such an extent that the supply air temperature increases. Okay, so that is how the capacity control is carried out. Now depending upon the required controls required in the season, for example in winter we may not have a cooling coil, we may simply have a heating coil and a humidifier, whereas in summer it may not be necessary to have a heating coil and the humidifier. Okay, simply a cooling and dehumidification coil may just serve the purpose. But sometimes if higher precision is required in controlling the conditioned space conditions, then all the equipment, that means cooling coil, heating coil and humidifier may be required. Okay, both in summer as well as in winter the supply air fan will be running and the return air fan will also be running. Okay, and here you can see the damper arrangements. We have the exhaust damper, and this is the recirculated air damper, and this is the outdoor air damper. So the damper positions can be controlled by a subsystem. By controlling the position of the dampers, you can control the amount of the outdoor air, thereby you can control the ventilation provided to the conditioned space. Okay, so this is a typical constant volume single zone system. As I said, you call this a single zone system because the conditioned space is monitored by a single thermostat. Okay, and this conditioned space could be a single room or it can consist of several rooms. Okay. And as I said, the cooling capacity can be varied by varying the cooling capacity of the coil. Okay, you have the coil here. For example, in summer you can vary the cooling capacity of the coil. There are two controls for varying the cooling capacity. One is what is known as the coil control. In coil control, what is done is the flow rate to the coil is controlled. That means if you are using a chilled water, then the chilled water flow rate is controlled. Okay. In the other control, what is known as phase and bypass control, this air, some amount of air is bypassed. Okay, so depending upon the conditioned space conditions. Okay, so this is what is known as bypass, phase and bypass control. Okay, and it is generally observed that space humidity can be controlled more precisely using phase and bypass control. It is difficult to control the space humidity, particularly in summer, using cooling coil control alone. And what are the applications of single duct, single zone, constant volume systems? These are applied in spaces with uniform loads such as large open areas with small external loads, that means basically for internally loaded buildings such as theatres, auditoria, departmental stores, etc. And these are also used in spaces requiring precision controls such as laboratories, where you have to control the temperature and humidity precisely. And you can also use multiple single zone systems in large buildings such as factories, office buildings, etc. Now let us look at single duct constant volume multiple zone systems. In these systems, all the air is cooled and dehumidified for summer or heated and humidified during winter to a given temperature and humidity ratio. A constant volume of this air is supplied to the reheat coil of each zone. In the reheat coil, the supply air temperature is increased further depending upon the load on that zone as sensed by the zone thermostat. And the reheat coil may run on either electricity or hot water. So let me show the schematic of this system. So we have here a single duct constant volume system with multiple zones and reheat coils. You can see that this system is almost similar as far as this portion is concerned, because you have the return air fan, supply air fan, cooling coil, heating coil, or the humidifier, and all these dampers. Okay. Only difference is that this system now caters to several zones, okay, several zones with different requirements, for example zone 1, zone 2, zone 3, like that. Okay. So to each zone, what is done is the flow rate is kept constant to each zone. For example, zone 1 the flow rate is V1, zone 2 flow rate is V2, zone 3 flow rate is V3, like that. Okay. The volumetric flow rate of supply air is kept constant to each zone. So depending upon the load of each zone, the supply air temperature at this point is varied by varying the capacity of this reheat coil. Okay, reheat coil. In the reheat coil, what is done is either hot water, okay, hot water or steam or an electrical heater are used for reheating the air. Okay, and the capacity of the reheat coil is controlled by the zone thermostat here. For example, if you want to reduce the capacity for a particular zone, then you have to increase the reheat so that the temperature at this point will be higher. Okay, so the air is reheated to a larger, higher temperature so that it can take the reduced load of that particular zone. Okay, so this is a typical single duct constant volume system with multiple zones and reheat coils. And what are the advantages of this kind of systems? The advantages are they occupy relatively small space because we have a single duct, and excellent temperature and humidity control over a wide range of zone loads. It is possible to control very precisely the temperature and humidity okay, and proper ventilation and air quality are ensured under all conditions, as the supply air amount is kept constant under all conditions. Okay, so there is no problem as far as ventilation or indoor air distribution or air quality are concerned. However, these systems have certain disadvantages. They consume higher energy. Okay, why do they consume higher energy? For example, in this reheat systems, what we are doing is, for example, if you are using it for summer, you have to cool and dehumidify the air to a minimum temperature so that it can take care of the maximum load. Okay. Now, if the load on a particular zone is not maximum, but it is only a part load, then what is done is this cold air is heated, okay, so that it can take the reduced load. So what we are doing in this process is, first we are consuming energy in the process of cooling and dehumidification of the air to a very low temperature. Again we are consuming energy for heating the air. Okay, so you are losing energy at both places. So as a result, these systems consume relatively higher energy compared to other systems. Okay. However, you can reduce the energy consumption of these systems if you can design and if you can select the controls in such a way that at any given time at least one reheat coil is switched off. Okay, so that way you can reduce the energy consumption. You can also reduce the energy consumption by using waste heat in reheat coils, for example solar heat or heat rejected from the condensers. Okay, thereby you can reduce the energy consumption somewhat. Okay. And another disadvantage of this system is that simultaneous cooling and heating is not possible. For example, if zone 1 requires cooling whereas zone 2 requires heating, that is not possible using the single duct systems. Next, let us look at single duct variable air volume systems. Variable air volume systems are quite popular. They are also called as VAV systems. As the name implies, in these systems, a variable air volume of air is supplied to each zone in a multiple zone system, and supply air temperature is kept constant. In the constant volume system, volumetric flow rate is kept constant and supply air temperature is varied, whereas in variable air volume system, volumetric flow rate is varied, whereas the supply air temperature is kept constant. The amount of air supplied to each zone is controlled by a zone damper, which in turn is controlled by the zone thermostat. So, let me show the schematic of this. So, you have here the schematic of a single duct multiple zone variable air volume system. So, you have several zones, zone 1, zone 2, like that. Again you have the return air duct and supply air duct and a cooling coil. I am talking about cooling, let us say, for that means for summer air conditioning. So, air is cooled and humidified to a particular temperature and humidity ratio, let us say Tn humidity ratio, using the cooling coil, and this air is supplied to different zones using this fan, supply fan. Okay. So, to each zone the temperature and humidity ratio are constant. Okay. However, each zone may have different loads. Okay. So, these different loads are taken care by varying the volumetric flow rate. Okay. The volumetric flow rate of air is varied to each zone depending upon the load. How the volumetric flow rate is varied? The volumetric flow rate is varied by using a zone damper. So, if you change the position of the zone damper, then the amount of air flowing into that particular zone changes, and the position of this zone damper is controlled by the zone thermostat. For example, if the temperature inside the zone 1 drops, let us say, because of the reduced load, then the capacity also has to be dropped. So, the capacity is dropped by reducing the flow rate through the zone damper. Okay. So, the thermostat senses the lower temperature and it closes the zone damper, so that less amount of air enters into the zone, thereby it meets the required reduced load. Okay. So, the same thing happens in different zones, that is why you call it as variable air volume system. Variable air volume systems offer the following features: lower energy consumption as air is not first cooled to low temperature then heated. Okay. So, unlike in reheat systems, what we have done, we have cooled the air very much, okay, to a very low temperature and then we have heated it. So, as I said, we are losing energy at two places, first for cooling and then for heating. Okay. So, this problem is not there in variable air volume systems. In variable air volume systems, what we are doing is we are not cooling and heating, we are only cooling. Okay. Then we are controlling the capacity by controlling the volumetric flow rate. Okay. So, thereby you do not have any reheat coils here. Okay. Since you are controlling the volumetric flow rate by keeping the temperature constant, the energy consumption because of cooling will be same, but there is no energy consumption because of reheating, because you do not have any reheat coils. Okay. That is the reason why VAV systems are becoming increasingly popular, because of their energy efficiency. Okay. So, another advantage is that the energy consumption of the fans is also lower as air flow rate is varied according to the building load. If the building load is less, then air flow rate will be less. If the air flow rate is less, the power consumption of the fan will be less. Okay. So, that is how you get energy benefits both from the plant as well as from the fans. However, they have certain disadvantages. If the flow rate is too low, for example, when the load is very light, then the volumetric flow rate to that particular room may be very low. Okay. If it is very low, then the ventilation and room air distribution may be inadequate. Okay. So, this may affect the indoor air quality of that particular building. Okay. This is a serious problem with VAV systems. Another problem is that balancing of airflow could be difficult, particularly at light loads. Okay. So, these are two typical problems. These problems can be addressed to some extent by combining variable air volume systems with reheat. That means, we will have a reheat coil along with a variable air volume system, and the reheat coil is operated when the flow rate drops below a certain level. Okay. Next, let us look at dual duct constant volume systems. So far we have been discussing single duct system, now let us look at dual duct system. In the dual duct system, the supply air fan splits the flow into two streams. Okay, that is why you call it as dual duct. Both streams flow through two different ducts. One stream flows through the cooling coil and is cooled to about 13 degrees centigrade, while the other stream flows through the heating coil and is heated to about 35 to 45 degrees centigrade. In each conditioned space or zone, the cold and hot air are mixed in required proportions using a mixing box arrangement controlled by that particular